Hello, my name is Craig Gallen and I'm going to present for you the opennms-uk Challenge 4 entry by Solent, Airwatch and opennms-uk. This is called Sniffy 2. So we're based in Southampton, which is one of the largest cruise terminals in the United Kingdom. This is great for Southampton as a port, but unfortunately it produces a huge amount of pollution. And one of the issues which the city is facing is trying to understand the impact of the pollution from the port on the general population. Now, like most cities, Southampton does have air quality monitoring, but it can't afford to have many sensors about the city, and most cities only have 2 or 3 because they are very expensive to run. And so the requirement is, can we come up with a low-cost way of measuring pollution across the city, but calibrate it to the high quality sensors which the city already has in such a way as we get a general view of the pollution across the city. Now, Solent Airwatch is a project which has been set up by a number of people in Southampton looking at community air monitoring. The idea here is to encourage citizens in the city to build or acquire their own small simple, cheap air quality sensors, but somehow connect these to the cloud and by some means make that data available more generally across the city. So the challenge for Solent Airwatch is to accurately measure using low-cost sensors. And the way that they propose to do this is to use big data processing using neural networks. And this will calibrate the sensor data against the high quality sensor data and give us a good view of what's going on across the city. But there's another problem, and that is how to generically manage all of these sensors. Having 4 or 5 sensors is one thing, but if we manage to encourage the deployment of several hundred sensors across the city, or indeed if we wanted to roll it out across several cities, then we need some sort of platform that allows us to run this cloud-sourced environment. And it needs to be secure. It needs to make sure that these devices that people are putting in their homes are not going to suddenly go rogue and do horrible things. And it needs to ensure that the cost of installation and the cost of the life cycle is cheap and easy. Now, we believe that anything we do in this area needs to be more generally applicable than just what we need within Solent. So we are looking at doing something which is generically applicable across the Eclipse Kura platform, OpenHab or Node-RED or any other IoT device that could be managed by this solution. Our first focus is on the Java ecosystem. Eclipse Kura is a good platform which we believe could be used for doing the air quality measurements, but OpenHab and indeed opennms itself have data collector platforms, all of which can run within Carafe and on top of low-cost hardware such as Raspberry Pi. And so we believe that we can come up with a solution which allows the deployment and management of remote software in a Java IoT ecosystem, and then providing that data back to a central system which is then able to render it up for users. So our proposed architecture is to use opennms with an MQTT broker to collect data from remote Sniffy instances. Then the neural network processing uses the opennms measurements API to collect the data and process it as it has been placed in Cassandra, an OSQL database. Then we would use grafana or similar technology for data visualization, allowing us to see the amount of pollution over time or the location of pollution over time across the city. And then all of the boxes on the right hand side, the yellow boxes, are part of the solution in terms of actually managing the life cycle of this deployment. So where's our device inventory? How do we manage the software in the IoT devices? How do we manage authentication of the sensors? And we propose to use the TM Forum catalog and TM Forum inventory APIs in order to come up with a way of managing the overall infrastructure from a generic portal. All of these parts of this solution have been tested individually, but our requirement now is to put it all together into one solution. And our initial Sniffy instance was built using Python, and it worked very well. But again, we would like to move to something which is a bit more sustainable in terms of using Eclipse Kura. So, in short, what is our proposal? Our proposal is to put together an overall architecture for IoT based around OpenNMS and Cassandra and an MQTT broker. Our proposal is to use Eclipse Kura rather than the existing Python technology running within the Raspberry Pis in order to measure the air pollution. And we believe that using Kura will make a much more generically useful solution. And then we will build out various components to allow us to manage the software that's running on Kura and to be able to manage the devices as they're deployed. And then that will allow our citizen scientists to use their own portal to deploy their device and to see the measurements that are coming back. But more generally, we would have a community of scientists who are interested in air pollution looking across all of the pieces and being able to get a view of what's going on in our city, Southampton, but in other cities as well. So we believe this would be a very useful addition to the Eclipse Kura project. We believe that it will allow us to show a large-scale data collection infrastructure using open source, and we believe it will also generate something very useful for our own city in terms of pollution monitoring. So that is our presentation. Thank you very much, and we hope that we'll be able to report back later in the year on how we have done with the Open IoT Challenge number 4. Thank you for your time.